Hi, everybody. We're excited to have you join us today for our live webinar on the next wave of multi-domain service orchestration. Before we dive in, my name is Morgan Stern. I'm the VP of Automation Strategy at Itential, and I'm joined today by Stephen Schattenberg, one of Itential's solution architects. Stephen, can you take a minute to describe your role at Itential?
Absolutely. Thank you, Morgan, and thank you everybody who has joined us today. My name is Stephen Schattenberg. I've been with Itential for over 5 years. And my current role as a solution architect, I work with a variety of different customers, basically overseeing the solutions that are put in place to address their automation needs. My background is in software engineering. I'm not a network engineer by trade, but I've learned quite a lot over the years. So the value that I bring to most projects is through the perspective of a software engineer, which is what I think is important when you're automating stuff. So
Cool. Thank you, Stephen. I asked Stephen to join us because he's got firsthand experience on a number of multi-domain service orchestration programs. My experience has been a little bit more focused on strategy and architecture and design, while Stephen is the one who gets to spend time in the trenches, really working with folks who are executing on these large-scale orchestration projects. One piece of housekeeping, during today's webinar, we'll be having an open discussion and dialogue around a number of topics related to multi-domain service orchestration. You can ask your questions along the way in the questions panel, and we'll answer them as best as we can. If we don't get to your questions by the end of the session, we'll reach out to you afterwards. So let's get started. Just to give you a sense of where Itential sits in the multi-domain service orchestration space, the Itential platform has executed more than 5 billion automations and orchestration flows across a diverse set of networking domains, a bunch of different use cases, some which are very domain focused and others which are multi-domain service orchestration. And we operate across multiple verticals. So we've got existing customers in the telecommunications space, managed services, financial services, public sector, as well as a variety of enterprises. Today, 4 of the top 4 US service providers and 6 of the top 10 service providers globally are using Itential to perform orchestration and automation. Some of our notable accounts are Lumen, where we're doing a large-scale network as a service implementation, S&P Global, and TPX. Just to start to set the groundwork, and I think this is something that became more clear to me as we started deploying some of these large-scale multi-domain service orchestration implementations. Started to see a pretty significant divergence in terms of requirements for multi-domain service orchestration activities versus domain orchestration and domain automation activities. And some of it was real logical, right? Within the domain, the primary traffic flow is going to be between the domain controller and the network elements. So you see a high level of transactions that are going southbound into the network. What I think I didn't quite appreciate was the nature of the traffic at the MDSO layer, at the multi-domain orchestrator layer, was much heavier going to the east-west systems, right? So talking to things like inventory, talking to databases, talking to service assurance, talking to topology. So it was like orders of magnitude higher traffic east-west and a lot faster. And so that has sort of shaped the way that we think in terms of design for some of the service orchestration use cases, both in terms of what do we need to support from a transactional volume and capacity and performance standpoint, and then also from a placement of services. So where we place these services, we need to do that really consciously, thinking about where are those systems that we're interacting with, what's the reachability with, and latency to those systems, because it starts to matter when we're getting into the high volume of traffic. The other thing that we started seeing as becoming really very important around the MDSO layer was flexibility within the data models. That in most cases, the domain-specific automation and orchestration platforms are really hard-coded to a specific data model. So a controller for an IP network services, things like routers and switches, is really hard-coded around those versus something that's performing more cloud-centric control is really oriented around a different set of objects. And so at the multi-domain layer is really where we need to start to think about, okay, how do I create a schema that is going to be flexible enough to accommodate some of the components that I need to have at that layer and be able to interact appropriately with those systems that are south of it. Within the domain orchestration space, then we started seeing like capabilities around lifecycle management, configuration management, some of the automation capabilities. That's where they were really centralized. And so if you think in terms of MDSO layer, it's really about, can I manage east-west and can I manage across the domains? Within the domains, I need to have a robust enough tool set to be able to connect to the systems that they need to connect to and provide the level of functionality and capability that are like domain-centric and specific.
Yeah, one of the things that I'll add to this slide is that the scale of manual operation is obviously not the same as the scale of automated operation. And so one of the things that I see often working with various organizations is that we, learn from folks that, hey, as I'm automating this thing, I need you to talk to this system and get some data from it, or I need you to enter some data into some system along the course of the automation, because that's what I do when I'm manually doing this stuff. And that works fine, but when you speed it up, times 1,000, which is what an automation is attempting to do, we sometimes see that those other systems can either struggle with that scale, or that the logic of the operation needs to be adjusted such that we don't overload those other systems. Particularly with the east and west stuff, which in the multi-domain world, you often have to talk to a variety of different systems to get data or even normalize data, because your domains may be expecting different formats or different information entirely.
Good points. Thank you, Stephen. Another topic that became really more clear to us as we started engaging some of these large-scale projects was reinforcing the distinction between server availability and service availability. In that, when we were working with folks on the requirements side, a lot of times the focus was on availability of like the orchestration server itself. And so there would be a fair amount of energy focused around how can we ensure high availability of the server? How do we do placement of the nodes so that we've got some level of redundancy and geo-availability? One of the key findings was that level of availability was only one part of a much larger set of services in the system that dictated what the availability of the orchestration service would be. And what I mean by that is the ability to activate a customer or perform an orchestration flow was always going to be limited by some link in the chain, not necessarily the orchestrator. It could be availability of an inventory system. It could be availability or speed of a southbound controller, right? So in situations where we are orchestrating a service and perhaps some of the endpoints within that service orchestration are slow to respond, well, then the speed of orchestration is going to be limited by that. So the implication of this has been that we really have tried to reinforce the importance not only of saying, let's make sure we design for high availability of the server, but let's be realistic about what availability of the service will be by doing some systems analysis and understanding where are those points at which they can be troublesome, and perhaps we come up with some mitigation strategies around that. I know, Stephen, you had a good example of this one if you wanted to bring it up now.
Yeah, sure. There was a project that I was involved with several years ago that at one point needed to get a normalized address so that they could send a technician to a location. And that was a small step in a much larger automation that we were performing for them. And because Itential is not a address normalizer, that's not our strong point. We relied on the public APIs for the U.S. Postal Service, and at one point we ran into some issues with that service because that service was having issues. And we could no longer perform that normalization step in the automation, which obviously caused a pileup. And from the perspective of the organization that was doing the automation, it appeared that Itential was having trouble, but the reality was that Itential was fine, and it was just a small percentage of automations were not able to complete because of one of these dependencies. So the question of availability is the more systems you integrate with, the more dependencies you have, the harder it really gets to define, and a lot of it is outside of your control and even Itential's control in some cases when we're dependent on third parties. So how you define availability and the successful uptime of the system, it becomes a very complex equation the more things that you're integrating with, the more dependencies that you have. So it's almost like you need to measure something different. And just keeping the servers up is great, but how many automations are you completing in a day versus how many are not being completed in a day is almost a better measure when you start getting into complex multi-domain orchestration type systems.
Yeah, that's a good point. And this is something that we've seen in multiple places, that while the orchestrator may become sort of the focal point for if something isn't happening, a lot of times it's some other component in the chain. And the reason the orchestrator is the focal point is because it's in the middle of everything, right? One of the other things that we have been doing a lot of work is in the space of service design and service composition, in that we see a real desire for a lot of organizations to move towards a network as a service implementation style, meaning I can expose all of my network capabilities as an API or as a service that can be consumed by internal and external stakeholders. Now, there are some really good efforts that are happening, and I think some of it's being driven by some industry organizations around how services are composed, right? If you look at things from Telemanagement Forum, for example, in their taxonomy, in the service provider space, the highest level would be a product, which is the sellable thing or the consumable thing. And there are analogs to this outside of service provider world, right? That's essentially the thing that somebody requests. That request, that product, is comprised of multiple, what they call customer-facing services. Those are the components that people understand. So I may buy a package from Google that has high-speed internet via fiber. It has a video service from YouTube. It may have a telephony service as part of it, right? Those would all be the customer-facing services that comprise the product of home internet. Then composing each of those customer-facing services are what they're calling resource-facing services. That would be the components of configuration that are actually aligned with the various parts of the technology infrastructure that are in place. So for me to provision a fiber customer, I've got to be able to talk to the OLTs. I've got to be able to talk to the billing system. I've got to be able to talk to all these different bits and pieces within the network at the IP layer potentially. That's all of the different components of the resource-facing services. So you have this logical hierarchy, and I think one of the things that we have found is that that logical hierarchy can be manifested in a number of different ways. You can kind of do a strict implementation where you try to adhere to that, but more times than not, what you recognize is there are times when some of these components may be nested within other components, which is totally cool by the way that the standards and specifications are written. But what we've started to see is that there's another set of implementation choices that seem to be advantageous for folks that exists, I would say, alongside this kind of service composition, which is when we're designing orchestration flows that look like workflows or processes or whatever. There's this layer that we can incorporate into the implementation that we refer to them as parent flows and child flows, right? The parent flow is defining the overall steps. The child flow, a lot of times, is defining a sub-process of that step, which may or may not be resource facing, right? That's, to me, one of the distinctions here between RFS, CFS, everything else. I can use this kind of modular approach to get better flexibility in the way I do an implementation. I get better separation of concerns and activities. So there may be teams that are responsible for sub-processes, and I don't want to constrain their ability to own that piece by lumping it into something larger and more monolithic. Like, the trend is moving towards modularity for a good reason, that provided you have the right design and the right infrastructure and the right practices and procedures, you get flexibility, you get the ability to make new kinds of combinatory services, you get a lot of benefits. In one circumstance, for a service orchestration flow, we implemented a parent flow to talk about the overall steps for instantiating a 5G core set of elements like UPF and SMF. At the same time, the folks wanted to have some ability to have different vendors in the mix. And so we created different child flows to represent the different vendor specifics so that we didn't have to interrupt the main logic, but could put in the pieces that we need to. In that case, it kind of straddles the line between some things that look very resource facing and some things that are more customer facing.
Yeah, in software design, we refer to this as abstraction. And the easy way to think about it is, how would I describe an automation to an executive? Well, I might stand in front of a whiteboard and draw, 3 or 4 boxes and say, the first step is we gather all the data. And the second step is we create the service. And the third step is we test or verify the service. But we all know that it's not so simple. And so, through abstraction, what we might do when we're building an automation is, have the top layer of the automation really be simple so that you can, easily describe it. But as you get into more of the detail, then you start to abstract the detail away so that, well, when I gather the data, I actually am performing 4 steps there. And one of those steps is I have to determine where the customer is located. So then now you're abstracting now even further. So now if they're in California, I'm going to do this, set of steps. And if they're in New York, I'm going to do this other set of steps. And eventually you end up with a tree of abstraction. And, the people who are building these things are the subject matter experts in those various levels. And it's kind of like, if you were touring a kitchen, your favorite restaurant, right? Because they make your favorite dish, the manager of the restaurant would probably say, well, over here on this side, we make the salads, and over there is where we cook the meat, and over here is where we prepare the desserts. And in a lot of cases, that's probably good enough. But if you really want to know the difference between how they grill the chicken and how they grill the fish, well, then you would walk over to the grill and talk to the person who does that part. So defining the points of abstraction is really critical, and it's a step that I like to put a lot of effort into.
And it becomes really essential, I think, in a lot of cases, to the success of the effort, right? Like you can carve things up a lot of different ways, but it's really about how manageable and maintainable is it along the way. And in our experience, it's been really interesting to see the evolution of orchestration flow design and workflow design. In that early days, things looked very linear. Like I do this step, I do this step, I do this step, I do this step. And then people realized that that wasn't a very good reflection of the average day. Like that represented like the super sunny day. And so people needed to start building in more logic for accommodating the reality of how networks and systems operate. And so you do start to see things look much more like a software kind of thinking in terms of how do you build the logic in than some sort of just straight blueprint that's always going to be the same way every time. So kind of transitioning into another step, I think this is something that is, I think, a challenge that's facing any organization that is thinking about doing large scale orchestration. That it is very tempting and a logical and kind of normal inclination to try to solve for 100% of the problem up front. And so the outcome of that is usually not great, in that you spend a lot of time working out, so in some cases, very edge cases, just to make sure that you've got coverage. And you spend so much time doing that that you're losing a lot of opportunities to actually gain real experience and to solve for real problems. And Stephen, I know you have a lot of experience in dealing with this situation, so I'd like to say a couple words.
Sure, definitely. Here a good analogy is, how do you want your dream backyard to be? And it's very easy to jump right to the end state, and we all know it. And that part is easy to capture and write down, right? I want a pool, I want a garden, I want utility shed, I want a pretty path, and all those things. But if you really attempted to do all of that at once, it's going to be a big mess. It's going to cost a lot of money, and your backyard is going to be unusable for, many months. And so the better way to do it is to, prioritize the parts that you understand the best, or prioritize the parts that cost you the most money, and put those at the top of the list and build them so that they work well. They don't always need to be perfect, because to have an automation that can handle every single edge case is, I just don't think that you'll ever get there. And so when I'm working with organizations, I really stress for them to, focus on the goal that you're trying to achieve, right? And if we go back to the garden analogy, if you're focused on, just trimming the trees, then let's do that, and let's do that really well, and let's get that part done. There's a temptation, I think, among folks that are on this journey to build the perfect automation, and it's obviously a great goal. But what I like to stress is, don't worry about the perfect, worry about putting something on production and running it, and showing, your company that this can be done, and measure the results. And if you automate, 80% of it really well, and there's 20% that falls out for a variety of reasons, maybe it's edge case stuff. Well, that's 80% of it that's been automated, and that's quite a good figure that you can, show your number. And often the goal is, I want to automate the stuff so that my workforce can focus on, the real engineering, and not, filling out spreadsheets or whatever it is that they might be doing. Another specific use case that I can call attention to was, there was an organization that we were working with that was a little unsure of where to begin. They knew they had a lot of potential to, automate some stuff and really make an impact in their business, but they were also a little doubtful of the technology and the solution. So they did not actually go for the legacy stuff, or the things that were going to give them the biggest return on their investment. They opted to go for a more greenfield, brand new service that they were offering, because it allowed for them to have the flexibility to make a lot of mistakes and gain experience, and at the same time, not expose the entire business to a lot of risk, by trying to, do things that they were not ready to do yet. And after they got through that phase of their automation journey, they were able to take what they've learned. They gained some experience with automation and with the tool of Itential and things like that. And then they started addressing the harder challenges, like replacing legacy systems and legacy services and stuff. So, I think the wisdom there is, don't let the good be the enemy of the great. And, you can automate a portion of your, stack, or, service, or whatever it is. You don't have to automate everything all up front.
Yep. Good points. Good points. Real quick, just kind of one clarification on terminology for everybody. I recognize in different segments, there's some very precise definitions around automation and orchestration. You'll notice Stephen and I kind of use them interchangeably sometimes. I think that's just more a function of the world that we operate in. What we're talking about here kind of applies really, like, thinking in terms of orchestration and automation. So just like, we recognize that some segments are very specific about how those terms are used, and we don't want to confuse people. So we're essentially talking about orchestration and automation within that. So one other quick comment on this. The analogy I like to use is scaffolding, right? That the worry about starting with something up front is that you're going to implement yourselves and design yourselves into a dead end, and that work then becomes stranded and not reusable. And so what I'd like to try to say is, think in terms of the role of a scaffolding when you're building a building. It pretty much defines the boundaries of the building, the structure of the building, the shape and size of the building, but it isn't the building itself. It just gives you enough framework so that you can operate within and build out the pieces and create the rooms that you need first, or the floors that you need first, and then build on top of that. So it's really about understanding how do I best define the boundaries of what I want to do, so that, and also what are the core principles of my design, such that I do get the flexibility and reusability, extensibility that I want to have and will require in the long term. Okay, this next point, this is another one that I think it represents a level of maturation in the industry, that when you're creating orchestration flows, it isn't really just a matter of saying, this is my current business process in the human manual world, and now I'm going to perform the same steps in the same order as an orchestration flow. That there are a lot of reasons why that's a logical conclusion to make, but the reality is there are opportunities and there are also challenges that turning something into an orchestrated automated process presents to itself, right? There are significant advantages in recognizing that the orchestrator doesn't work 9 to 5, doesn't take lunch breaks, doesn't make manual data entry errors, right? At the same time, it's going to take what it gets, right? But knowing that and knowing that you can do things in parallel gives you dimensions of flexibility and performance and optimization that you would never get in the manual world. Stephen, your thoughts on this?
Yeah, I think, whenever I start with a new project, there's often this overwhelming sensation, I guess, from the people I'm working with of, well, how do I start? What do I do first? And I think that you have no choice but to start with the manual steps that you're currently doing, because that's what you know. And that's what defines the thing that you're trying to automate. So don't fight that urge. Just start with that, right? Come up with the list of steps that you take in order to create the service or the thing, whatever you're automating. And especially among, software engineer types, they're very quick to point out areas where either it's inefficient or requires optimization. You'll have plenty of time to do that, because if you think about what the goal of an automation is it's repeating the same set of steps over and over and over and over again. So don't get bogged down in the premature optimization, right? You're going to have plenty of time once you have your automation running in production to experience the failures, to experience the inefficiencies. And so at that point, that's when you start to apply the optimizations. And, I think it was, I think when NASA builds a rocket, they don't just build one, they build two, because they have to learn from the first one. And so what I recommend to people is don't prematurely optimize it. Let's just follow what you know, which are the manual steps, and then put it in production and run it 1,000 times. And you'll find out very quickly which parts are working well and which parts, could use some optimization. And it could be that through the course of running it 1,000 times in production, you're going to find out that those manual steps might be completely wrong when you are doing it in an automated fashion, for a number of reasons. One, it could have something to do with what we discussed in, I think it was the second slide, where the scale of automating something is different than when you're doing it manually. And you may discover that steps number 4, 5, and 6 actually need to be steps number 2, 3, and 4, so that you don't overload something. Or you may decide that steps 7, 8, 9 can really be reduced to step 7. But you're not going to find that out unless you take the steps and move on the journey. And the perfect and the logical place to start is with the steps that you know already today, and just start with the manual steps, and then you can optimize it later. The other thing that we find is that it's tempting in an automation to do things one at a time, because hey, I can open up a port on a switch. I can do that 1,000 times one at a time, and it works fine. But it might work faster if you do it in batches of 50 or things like that. So those are all the kinds of things that you'll discover as you run these things in production.
There's a piece to this that's not stated on the slide, and maybe for version 2 of this, we will incorporate this. But the kind of underlying message here is that it is going to be very important to build the ability to collect information from your orchestration platform, because you get the opportunity then to take a look at a data set that you would never be able to get any other way, and start to analyze what's happening in some of these orchestrated processes, right? So for those of you with any kind of process background, you know that the problematic processes are the ones that there's a high level of variability, right? If a process always takes an hour every time and it's, within a couple percent of that, it's really easy to build a plan around that. But if there's a step that can take 2 seconds or 3 hours, that really adds a level of unpredictability and uncertainty into the process flow, which that means then you've got to engineer for worst case scenario. And when you start to stack those, that really changes the way SLAs need to be designed and everything else. And so what you'll get once you instrument for this kind of data collection is you'll very quickly be able to zero in on those areas where you've got either SLAs being routinely exceeded or you have a high level of variability. And then you can drill down into that and say, well, why is that? Is that because of a system? Is that because of a network device? Is that because there's a human manual step there, and the ability for that person to get it done is gated by maybe external factors or SLAs? So you start to get this insight that really becomes advantageous in being able to take idle time out of the process to improve predictability, which then ultimately means you can make better business decisions and get better overall utilization of the system.
Yeah, I just want to make one comment there, Morgan.
Yep.
It's never a good idea to build into your automation process something that has that really high degree of variability and with time. And a good example might be when a customer buys our internet service, do I have to deliver something to their house? Because that is outside of automation completely. You cannot automate UPS, right? And you can't really depend on them in an automation either. It might take them 2 days to deliver a package. It might also take them 2 weeks. So, one of the things that I like to work with organizations on is really defining those boundaries, because that would indicate where one automation ends and something outside of everybody's control occurs, and then another automation would start.
Good point. Good real life experience there for sure. The next area we want to talk about is the criticality of data as part of large scale, like multi-domain service orchestration activities. I think that this is become, in a lot of circumstances, the gating factor in the ability to transition processes that maybe have a lot of manual components to being fully automated or fully orchestrated. That the quality of data becomes essential. And we know from real life experience, right? I've been in the industry for a long time. And if there's one of the things that's almost always true is inventory systems rarely, and I mean like 5% of the time, are reliable enough that I can just run fully unattended. So you then need to start to decide, how do I want to manage in a world where maybe I need to think about multiple sources of truth just from a practical standpoint. Stephen, your thoughts?
Yeah, data validation becomes a really crucial piece, because you are essentially assuming and also entirely dependent on the quality of the data that is often found in systems where that data originates from human entry, and it might be many years old. And what happens is, people are doing their jobs over the years, and things change. A particular war story that comes to mind is there was a system that had its own set of problems. with, I think, how you would use the search tool in that system. And so some smart people figured out that if they used the phone number field to put a person's name, they could do their job faster because they would get around this weird search problem that they had. But that then created a really bad data integrity problem, where now when we went to automate systems, we were expecting a phone number, and instead we would find a person's name. And, you know, I'm sure that every company is going to have their own version of that story in one shape or form, where either intentionally or unintentionally, the quality of the data that's there is not good, which then makes it unreliable. And then you start to run into the issue with, I'm never going to be able to automate 100% of these things because I know that somewhere along the way, I'm going to encounter some strange piece of information that was not expected to be there. And that's a challenging problem to solve. You can either fix it at the source, which can be expensive and time consuming, or you can try to leverage the automation to either handle those exceptions or validate the data on the fly. It's hard for me to really prescribe the best answer because it really depends on the situation. You know, if you're talking about a database of 100 records that, you know, 2 of them are wrong, well, then you fix it at the data source. But if you're talking about something that, you know, is routinely returning things in lowercase, well, then you would fix that in the fly in the automation to uppercase the data. And so it's guaranteed to be something that you run into on your automation journey, is the data integrity.
And kind of with this in mind, I think, you know, a lot of what we've been talking about has been pretty generic. I think the way that we sort of help our users to address this is through a couple of different capabilities. One is we're providing a lot of tools so that you can operate in a world that may be driven by multiple sources of truth, and that there may be some times when the network needs to be authoritative, and so we want to provide tools to do that. One of the other areas is around this notion of data manipulation and data transformation, and that seldom do I get a payload from one system that I can just sort of plug into another thing. I need to do some level of decomposition. I may need to augment it. I may need to validate it. I may need to do a lot of different things. With that in mind, within the Itential platform, we've got a capability called JSON schema transformations, which makes it significantly easier to work with those kinds of data payload transformation operations so that you don't have to write scripts or do any of the other things, because we've just found that this is a really common thing. And if we can help folks to simplify that and be able to use that as an object within larger orchestration or automation flows, it just gives them that much more velocity. So as we're kind of winding down on this, I wanted to give Stephen an opportunity to further talk about, you know, like first to synthesize some of the things that we've talked about, but then also to really hammer home some of the things that we are learning, both in the way we're helping organizations implement orchestration, and also in how we're helping folks to design some of these services and some of these service orchestration flows. So, Stephen, do you want to kind of talk to the points of like what are things people can do that are tangible to help them get started?
Yeah, you know, I think that if you have an opportunity to automate a portion of a larger process, then you should start with that, because, you know, it's really hard to boil the ocean. And also, you know, drawing on the previous comments that I made, you know, you're gonna learn from your experience. So, you know, putting things in production is a really good goal, and you have to fight the temptation to make something pretty and perfect, right? The goal of automation is automating something. It's not designing a perfect piece of software. And, the reality is that a lot of these business processes are covered in warts and have a lot of exceptions. And so the automation is more than likely going to reflect that. So don't fight that urge. Just get it done, basically. There's a good place that you can start is like I already mentioned, just the steps that you already know. But if you really want to hone in on some particular areas, data entry is a really good thing to automate. So you may discover that before you can automate your multi-domain service, you might have to fix a few things in your data entry process first. Computers are really good at making sure the data is normalized and the same. So that's a good thing to do. They're also really good at creating standard configuration files and things like that. We've had a lot of success with organizations that we work with where they leverage our platform to generate those standard configs. Typically, you're going to have a lot of opinions at your organization on how a particular device should be configured. And it's generally not hard to ask someone to, if you could make the perfect configuration for this particular type of network gear, what would it be? Normally, people they'll answer that question very quickly, and they'll be very opinionated about it. And so that's often a good place to start. You have to always be thinking about where things are going to fail, because things will fail in an automation. They fail all the time. And a good automation knows how to recover from those failures. Maybe it retries various failures, or maybe it just kind of says, I can't do this, I'm going to give up. And it notifies a person that, this particular issue is thorny enough that we need the analytical capabilities of the human brain and not the machine. Yeah.
Okay. Any other points you want to make before I kind of wind things down, Stephen?
I don't think so. I think I've expressed myself.
Okay. Well, that's great. I wanted to thank everybody for your time today. We really appreciate having the opportunity to share some of our experiences and findings in the multi-domain service orchestration space. We see this as a really interesting set of activities that we're working with a number of folks on, and in a lot of different capacities. If you have questions after the session is done, or if you would like to talk more, please feel free to reach out to us. There's some contact information there. If you already have a relationship with the Itential account executive, they know how to get a hold of us. But once again, I want to thank you for your time, Stephen. I want to thank you for your contribution. That was really great. And we will be seeing you in other webinars in the future to talk about related subjects. So thank you, everybody.